Alright, it's getting close to the end of chapter 9. It's a rough chapter for sure. I feel bad we're not in school doing it. Alright, so lesson 934, combining functions. Not the world's worst thing. It's pretty easy actually to do this. Some of the questions are a little bit crazy, but on the whole it's a pretty simple idea at least. So in the previous lesson, you learned how to build a new function by using pieces of familiar functions. In this lesson, you will investigate how you can build a new function by combining functions through addition, subtraction, and multiplication. Whether you remember this or not, you did a little bit of this in Integrated 1 just quickly towards the end of the year. So consider the constant function c of x equals 3. So that means it's just always 3. The quadratic f of x equals x squared, so it's going to be a parabola, and the linear function g of x equals 2x plus 1. Rewrite each combination of functions as a new function and state whether the new function is constant, linear, or quadratic. Again, constant means there's no x, quadratic means it's x squared, and linear means it's x to the first power. So let's go ahead and do that, and we will add, subtract, multiply, and divide these things and see what we come up with. So a of x is f of x plus c of x. Well, f of x is x squared, so again we're just adding these together. X squared plus c of x is 3. So that's what we get here. This is just going to equal x squared plus 3. That simple. If we go to b of x is going to be whatever we get when we take c of x times f of x. So we're going to multiply 3 times f of x, which is x squared. So obviously we just get 3x squared. D of x, that makes no sense. That wouldn't be c of x, but whatever. All right, so d of x is going to equal g of x, which is 2x plus 1, minus, and you'll notice the way I do this, I'm going to put this whole thing in a parentheses just so I don't get screwed up with the order of operations, but minus c of x, which is minus 3. So I get 2x plus 1 minus 3, so I get 2x minus 2. So that's what this one's going to equal. It's going to equal 2x minus 2. So you can see, not too bad. We're just combining functions. And again, I do want to talk about the notation that this is d of x. d of x equals 2x minus 2. A of x equals x squared plus 3. It's also could be saying, you know, I didn't mean to do that. Okay. Can also be a of x equals x squared plus 3, or f of x plus c of x equals x squared plus 3, or a of x equals f of x plus c of x, or f of x plus c of x equals a of x. They all equal each other, so it doesn't really matter how that is written there. By the way, that's going to be a equal sign. All right, and then we'll go to e of x, and e of x is going to equal c of x, which is 3, times g of x, which is 2x plus 1. You'll notice I put it in parentheses so I know to distribute. So I get equals 6x plus 3. So we get these four different combinations of functions when we combine these functions. Let's go ahead and jump to the next problem. So now we're going to 9:15, and they're actually going to give us a resource page to this, which I'm going to open up and do it, but we'll read about the question first before we go over that. So it says, what will happen if you combine a quadratic function with a linear function? Oh, I'm sorry, we never answered these questions here. Shoot, I don't know if it's too late to go back. Oh, it is too late to go back in time. Darn it. We should have mentioned if they were linear or if they were quadratic. The long story short is if it had an x squared, it was quadratic. If it just had an x, it was linear. And if it didn't have either, it was a constant. So I apologize, I missed that part of it. All right, so it says, what will happen if you combine a quadratic function and a linear function? You will investigate this question using tables and graphs. We can consider f of x equals x squared and h of x equals a half of x plus 1. So here's a quadratic, here's a linear. It says, obtain this resource page, record the values for f of x and h of x for -3 to 3. So that's our domain, right? We talked about piecewise functions. We don't care about when x is negative 4. We don't care about when x is positive 4. We only care about between negative 3 and 3, including negative 3 and 3 because it says equal to. Then make a precise graph of each function and label the graphs. So complete the table for j of x and k of x, and it gives us some instructions on that as well, just to add those functions. So I think it makes sense at this point to jump over to that resource page so you can see what it is that we're talking about. So as we go here, it wants us to fill in this table, and there's a lot going on with this table, so I'll sort of fill it in as we go. Kind of be patient with me here. So first of all, what happens when I plug negative 3 in here? Well, it's negative 3 squared, so I get 9. Negative 2 squared, I get 4. Negative 1 squared, I get 1. 0 squared, I get 0. 1 squared, I get 1. 4, and 9. I hope you're all okay with plugging those in. What happens when I plug in negative 3 here? Well, I get negative 1½ plus 1, so I get negative 1/2. Here I get negative 1 plus 1, I get 0. Here I get negative half plus 1 is 1/2. Here I get 0 plus 1 is 1. Here I get 1½ we'll just call it 3/2. Here I'm going to get 1 plus 1 is 2. And here I'm going to get 1½ plus 1, so it's going to be 5/2. So that's what we get when we plug these in on these. Now what happens when we add these things together? When I add f of x plus h of x. Well, when I add f of x plus h of x, I'm going to get x squared plus 1/2 x plus 1. So you'll notice when I plug negative 3 in here, I get 9, right? I don't know where a good place to write all this is. I guess I'll do it down here. X squared plus 1/2 x plus 1. So when I plug negative 3 in, I get 9 minus 1½ plus 1. Well, that's going to give me 8½. And what happens if I plug in negative 2? I get 4, right? Minus 1 plus 1. So I just get 4. And what happens if I plug in negative 1? Well, I get negative 1 squared is 1. Minus 1/2 plus 1. So minus 1/2 plus 1. That's going to give me 1½. This one I probably should have put like minus 1 plus 1 just to finish that off. I think you're noticing a pattern, hopefully. What is 9 minus 1/2 is 8½ What is 4 plus 0 is 4. What is 1 plus 1½ is 1½. So I'm guessing I'm going to get 1 here. So let's go ahead and see, what do I get when I plug in 0 here? 0 plus 0 plus 1, I get 1. What do I get when I plug in 1? 1 plus 1½, I'm guessing I'm going to get 2½ right here, but let's see. 1 squared is 1, plus 1/2, plus 1, and I do get 2½. So I think we've noticed a little trend here that I can literally just add these things up. This is going to be 2.5, so I'll just call this 11.5. So kind of interesting that we're able to do that. And the reason why I want to use resource pages, I think it makes it more clear kind of what's going on here. So what happens when I subtract? I mean, in theory, what should happen is I should get 9 minus 1/2. I'm sorry, minus a negative 1/2. That should add and give me 9.5, right? And 4 minus 0 should give me 4. And 1 minus 1/2 should give me 1/2. So let's see if that's the case. F of x is x squared minus h of x. And this is what I was saying. I think it's important to put this in parentheses so that you distribute that negative. It's really easy to get screwed up doing these things where a lot of kids will just say x squared minus 1/2 x plus 1. Well, it's not plus 1, it's minus 1 because I'm subtracting the entire thing. So now let's plug in that negative 3 and let's see if I actually did get 9.5. So if I plug in negative 3 squared is 9. A negative times a negative is plus 3/2 or plus 1.5 minus 1. I get 10.5 minus 1 is indeed 9.5. Well, what if I plug in... Geez, I'm so indelicate with this. It's frustrating. What if I plug in 4? I'm sorry, negative 2. Well, I get 4. So negative 2 squared is 4. A negative half times negative 2 is indeed plus 1 minus 1, and I do get 4. And if I plug in negative 1, negative 1 squared is 1 plus a half minus 1, so I do get a half. So I think the same thing. 0 minus 1 is negative 1. 1 minus 1 and a half is negative 1 and a half. I'm sorry, is negative 1 half, my mistake. 4 minus 2 is 2. And 9 minus 2 and a half should give me 6 and a half. And again, let's just check that last one just to make sure we're not crazy and we're not screwing this up. So I'm going to plug in 3. 3 squared is 9 minus 1.5 minus 1. So 9 minus 2 and a half is going to give me 6 and a half. So that seems to make sense. So we got a nice little pattern here. It does seem to be going pretty well. So what happens when I multiply these things? So let's multiply and let's see what happens. So if I take f of x, which is x squared, and I multiply it by h of x, which is a half of x plus 1, I'm going to have to distribute. So I'm going to get 1 half x cubed plus x squared. So kind of interesting thing there. I'm going to go ahead and put this back up towards the top. So we haven't dealt with anything yet that has a 3 right here, and you will in integrated 3. It's known as a cubic. So let's go ahead and see a little bit about what's going on. So first of all, again, my assumption is 9 minus a half. I should get negative 4.5 here. So let's see if that's actually what I get. Let's plug negative 3 in. Again, I have to do the exponents first. So I have to do negative 3 to the third power plus negative 3 squared. So negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So I have a half of negative 27 plus negative 3 times negative 3 is 9. Well, this gives me negative 13.5 plus 9. I do get negative 4.5. So you can see how this table works and how kind of convenient it is to have these numbers to fill in the rest of this table. So I would assume 4 times 0 is 0. So let's see if I get that. Let's go over here and let's go ahead and plug in negative 2. So again, I'm going to plug in negative 2 for the x. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So half of negative 8 plus 4. A half of negative 8 is negative 4 plus 4. I did get my 0. So I think I'm good. And 1 times a half is 1 half. 0 times 1 is 0. 1 times 1 and a half, we'll call it 1.5. 4 times 2 is 8. 9 times 2 and a half. And you could see I could keep using this stuff, but I mean, I think we get the point here at this point. I hope at least. So 1822.5. So this is what we're going to end up getting. Now it's asking us to graph this stuff. So let's see here. At negative 3, I get 8.5. So this one we'll graph j of x. At negative 3, I get 8.5. That would be somewhere up here off the list. At negative 2, I get 4. At negative 1, I get 1.5. At 0, I get 1. I'm sorry, yeah, at 0, I get 1. At 1, I get 2.5. At 4, I get 6. I'm sorry, at 2, I get 6. What am I talking about there? So you can see I get a parabola. And that makes a lot of sense because my equation, this j of x, my equation ended up being x squared plus 1 half x plus 1. As a matter of fact, I should have written, so this is j of x. I should have written f of x. So I got x squared minus a half x minus 1. So on this one, I'll do k of x, right? So this is k of x, this is j of x. So same thing. When I plug in negative 3, I get 9.5. Again, that's off the board. At negative 2, I get 4. At negative 1, I get a half. At 0, I get negative 1. At 1, I get negative a half. At 2, I get 2. And at 3, I get 6.5. So something like that. So you can see this is the one that I get for k of x. So again, another parabola. But what is this one going to look like, this p of x? Because you'll remember we had like a cubic. So this one was 1/2 x to the third power plus x squared. That was our p of x. And I'll graph this one over here by itself. So at negative 3, I had negative 4.5. So somewhere down there. At negative 2, I had 0 as my output. At negative 1, I get a half. At 0, I get 0. At 1, I get 1.5. At 2, I get 8. And then it goes way out there. So you can see, kind of interesting. We're not used to seeing cubics. And again, this is p of x. So what's interesting about this, and I won't get too far into this, but you can see that these have x squared. If you take the exponent and subtract 1, that's the most amount of curves you can have. Parabolas have one curve. If you take the exponent and subtract 1, that's the most amount of curves you can have. You can see this has 2 curves. And again, think of a line. Y equals 3x plus 1. Well, that's an exponent of 1. 1 minus 1 equals 0. I have no curves. So kind of interesting. I've always found this kind of cool that no matter what the shape is, so if you say like y equals 5x to the 5th, 5 minus 1 is, well, I should say, let's go 7x to the 5th, right? So 5 minus 1 is 4. This shape can have at most 1, 2, 3, 4 curves. That's the most amount of curves it can have. So I've always, like I said, found that kind of interesting. All right, that is lesson 934.